Hello, welcome to the next topic of electric field intensity, Ncert as like first chapter. The next topic I have already written in the board: electric field due to continuous charge distribution. Electric field due to continuous charge distributions. What is the meaning of this one? Continuous. Continuous means the electric field we are going to calculate not with respect to one charge. With respect to single charge, we know the equation E is equal to 1 by 4 pi epsilon 0 Q divided by R square. R is the distance to the point where we are calculating the electric field intensity. That is for a single charge, Q amount of charge. But here, this is not for a single charge, this is for a collection of charges, which means continuous charge distribution. Not only one charge but consists of multiple charges. That is the meaning of will be here. Okay, in this topic, in this sessions we are going to see the continuous charge distributions are happening due to various objects, various size of the objects. Okay, various size of the object means you can see in my hand, you can see a duster will be here, right? So this dusters will have a consist of, suppose I am providing some charges to this duster. Okay, charging by conduction, charging by induction, first class we have learned, right? So due to any methods, if you are providing charge to this one, then charges will be spread over the surface of this one. Then that is a best example for a continuous charge distribution. Charges are continuously distributed. If I am asking you how many charges will be there, you cannot say one charges, you will say more than one charges in a very simple way. So we will see the continuous distributions on different bodies. For example, a metal strip that we are going to see what is electric field created by a metal strip which is in a straight wire, and we are going to calculate the electric field created by a half circle. We are going to find the electric field created by a quadrant circle, a quarter of a circle. Then we are going to find out electric field created by an arc of a circle. Okay, we will see one by one as like we have done for the previous session also. Here also we have subtopics are there. So hope you understood what I mean to say like continuous charge distribution. Continuous means not only one charge, it consists of many charges in short. Okay, so let's move without wasting the time, sir. So write on the first subheading, right? A, the first subheading, electric field. Just I am putting E. So electric field due to a charge strip. Due to a charge strip. Electric field due to a charge strip. Charge strip you can say. Sometimes you can also say charged line, just charged line, or you can say charged wire, anything. Okay, charged wire. So it is just like a strip, that's all. Okay, so I will draw the diagram will be here. So it is a strip like this, and the strip I am assuming for all the derivations I am assuming positive charges will be here. If positive charges will be there on the strip, what is the direction of the electric field intensity? It is away from the strip. If it is negative, it is towards the strip. So it is positive, so it is away from the strip. Now we are considering a point where we are going to find out the electric field intensity. Say I am taking this point. Here I am going to find out the electric field intensity. This is at a distance of a meter from the end of the road. And the length of the road is L meter. Okay, so how we will find out the electric field intensity? Electric field intensity due to this charge, we know E equal to 1 by 4 pi epsilon 0. For that 1 by 4 pi epsilon 0, here onwards I am going to write a K as a short form. So K is equal to 1 by 4 pi epsilon 0, that's all, into K into Q divided by distance from here to here. How much will say? A plus L the whole square. For this charge is over. What about this next charge which is very close to the first charge? What will come? You will say KQ, that charge divided by, what is this distance from the end? It is L plus A. Now this charge is not at the end, so A plus some other distance, that distance I don't know. So if I am, so this is, in short, suppose the distance from here to here I'm measuring as R, then I will say R square, like this. So I have another charge, so I have lot of charges will be here. So if I am keep on writing this equation and if I keep on adding all this electric field, it will never end. Okay, if I am doing this whole day also, I cannot calculate the total electric field, it's not possible. So what we will do in this case? In this case, we will use some method from mathematics. Mathematics is also called the servant of every language, right? Not only every language, every subject, because it is saving every subject. Without mathematics, we cannot do anything. So here also we are make use of mathematics. What we are going to do means, here we will strike a strip. A strip means a small portion of the wire, and I am assuming the small portion of the wire contains a dq amount of charge. Total charge is q. dq means small q, okay, delta q or dq, and this is at a distance of x meter from the dq to the point where I am going to calculate the electric field intensity. Okay, now if you say, if I am adding many number of dq, 1 dq, 2 dq, 3 dq, 4 dq towards right side, similarly if I am adding next dq, next dq, next dq, next dq, next dq towards left side, if you are adding all the dq's, what you will get? You will get the total charge, and every dq is creating an electric field on the right side, so we have to add all the electric field. So that is not practically possible. So what we are going to do means, we are going to find out electric field due to dq, that is called dE. Small charge creates small electric field, dE is a small. So what is the formula of this one? K into dq, K into q by r square, that's a general formula. Here what is r square? Distance from this charge to this point, you will say x square. Okay, now the dq is varied or changing from where to where. I can consider a dq at this point, right? I can consider a dq at this point on this black line. Similarly, I can have many dq's in between, and last dq will be at this point. Okay, so if I am adding all the dq's, I will get q. If I am adding all the electric field created by every dq's, which means if I am adding dE from here to here, then I will get total electric field. Okay, so in that cases, this is a starting point, this is the ending point. So in order to get, I need to get total electric field from small amount of dE. What should I will do? I will do an integration of differentiations, both will get cancels. So then I will get a big E. So I will do an integration here. If I am integrating on the left side, right hand side also I have to integrate. So here also I am integrating. What is the limit of integration? From where to where I can go? I can go from here. What is from here to this point, length A, and up to this. This is the last end. What is the length? A plus L. If I am integrating this process, then I will get the full E. So now dE integration is E. So E is equal to integral A to A plus L. Now it's purely mathematics. We are just solving the maths part. K into dq divided by x square. We have to integrate the right side so that our answers will get finished it off. Okay. So we are here. We are moving forward. Here in electric field intensity, we are now going to learn one term is called linear charge density. Write down linear charge density. Linear charge density. This is representing using a letter called lambda. Linear charge density. The meaning of lambda is charge divided by its length. That's all. Charge divided by length is called linear charge density lambda. Here I am going to replace this dq. So if I have, in case of a dq is a small piece and whose length, this strip length is called dl. So I can write for this small shaded area, I can written as lambda equal to dq divided by dl. Okay, L is the small l or capital L is the full length, Q is the full charge. If I am taking a strip, a small area, then small charge divided by small length will be equal to S linear charge density. So anything charge divided by length is called linear charge density. Here we are going to replace with dq. What is from this formula? dq will be equal to lambda into dl. This factor we are going to replace will be here. dq will be equal to lambda times of dl, and x is varying from a to a plus s, and k into dq divided by x square. This is what we are going to do will be here. The total length is dl, and the total length here you can see it is a total length is given as x. So x is varying. So normally if you have a full length L, then shorter length we will say dl. But here if I am going from the right side towards left, if I am going means what is actually changing? X is changing. X is changing means this dl is not changing. We can say dx is changing. So dl in this case is replaced with dx because x is moving from right hand side towards left hand side. So here at this point x is equal to 0, at this point 1 dx, at this point 2 dx, at this point 4 dx, at this point 5 dx. So it's keep on going, and how large number of dx will added will get L. So here instead of writing dl, in this case I am writing dq will be equal to lambda into dx. Hope you understood. Instead of writing dl, I am writing dx. Why? Because x is the varying parameter there. Now we are integrating this part and we are substituting. So integral a to a plus l, next stage writing integral a to a plus l, k into dq we are substituting lambda into dx whole divided by x square. Here common terms we are taking outside out of this integrations part, and k lambda is common, so we are taking out of the integrations, and integral a to a plus l into dx divided by x square. Dx divided by x square. What is the integral of x raised to n? X raised to n plus 1 divided by x raised to n plus 1. So one more steps, I am writing k into a to a plus l, x power minus 2, this 2 is going to numerator into dx. Now x raised to n integral. So k lambda into, we are integrating x raised to n plus 1. N plus 1 means minus 2 plus 1 divided by n plus 1, which means minus 2 plus 1. Integration is over. We have to apply the limit from a to a plus l. Okay, integration we are applying from a to a plus l. So what this will be finally coming? K lambda into, here x power minus 1, here 1 minus 1. So minus k lambda divided by 1 by x, limit of integrations a to a plus l, a to a plus l. We are applying the limits here, balance writing here, we are applying the limits will be here, minus k lambda into 1 by x. So 1 divided by a plus l minus 1 divided by a. We are simplifying this, minus k lambda a minus l whole divided by a into a plus l. A and a will get cancelled, this will goes out, this minus and minus will become plus, k divided by a into a plus l. This is the electric field created by, this equation is important, this is the electric field created by a rod of charge or a strip of charge or a line of charge or just a wire of charge. So the wire of charge we are going to find, we are calculating the electric field at this point. So this value of electric field is given, will be there. Okay, hope you understood. I will just go through this derivations once again for your understandability. Just once again I am repeating. Here this distance is a, we are actually taking a dq element whose distance is dx, and we are moving from right to left because we don't know how many dq's will be here. So we are going from one border to another border. Lower border limit a from this point a, upper border limit a plus l, k into dq by x square. Then we learned about one concept called linear charge density, lambda equations, lambda equal to q by l, dq by dl, and dl we are replaced with ds because x is the varying quantity will be here. We are moving from this border to this border, mean that x will be keep on changing. Okay, so dq into lambda dx, we are substituted, this dq will be here and solved by the integration process, and finally we got k lambda divided by a into a plus l. This is the electric field due to a continuous charge distributions given by a rod or a charge strips or a charged line or a charged wire, anything. But this equations, the final equations, what we are, what here it is written, it's important. Okay, hope you understood what is the meaning of charge distributions, how a rod created a charge distributions. Next topics we are going to learn about the second part, electric field due to semicircle. Now previous topic we have learned about electric field due to a charge strips or a charged wire, but here it is a semicircle. So let's move forward. First we'll see the diagram has like we have seen in the previous session also. I have a semicircle and this is nothing but a wire which is bent in the form of an half circle. Wire bent in the form of an half circle. We are going to find out electric field at this point, at this center point. This is the half circle's line, and we are going to find out the electric field intensity at this point. Okay, so earlier also we have learned about a strip or a line charge, but it's a straight wire, there is no bending, but now it is a half circle. Okay, so electric field produces by a positive charge, it's away from the charge or towards charge, it is away from the charge. So here also, as like we have done for a previous topic also, here also we are going to consider a strip, a small strips we are going to consider, and this strips will contains a charge of dq and whose length is dl. Okay, so dq comma dl I have written. So electric field at this point is away from the charge, and this angle I am make it as theta. Okay, you can consider any angle here or from the middle to right, left, anything. Here I am considering this angle as theta. If this angle is theta, this angle is also called theta. Okay, now this is an electric field created by dq. The electric field is called dE. So dE is the electric field created by the dq charge. Now this is an electric field vector and which is directing in this direction. Okay, in maths, if something is not in the x direction, not in maths, especially in physics, if something is not in the x directions or y direction, it's very hard to solve. So what we will do, we will split into two parts. That is called a vector resolving of the vector. Here I am resolving. This is like this one. So I need something on x-axis. I need something on y-axis. So y-axis and x-axis, I am splitting this vector. Here dE. So the angle is theta. So the side nearer to theta is called dE cos theta. The other one is called dE sin theta. Okay, you have learned in schools also, right? Cos theta equal to adjacent side by hypotenuse. So adjacent side will be cos theta will be equal to cos theta will be equal to cos theta. We'll write here. Cos theta will be equal to adjacent side by hypotenuse. So what is this adjacent side? This is an adjacent side. So adjacent side will be equal to hypotenuse into cos theta. So always remember theta, the side which is very near to theta is called dE cos theta, the other side is called dE sin theta. So it is clear. Okay, so now we have split it. Now if we have taken a strips will be here. So if some other student is came and he is taken a strip will be here also, what will happen? This will also create an electric field will be like this one dE, right? This will also create an electric field. This is also a dQ and a dl, but directly in the opposite side. This will also create a theta angle. So this can also be splitted as two parts, okay, on x and y axis. So on x and y axis splitting, this is called dE cos theta and this is called dE sin theta. So you can see dE cos theta here towards right, here also dE is cos theta towards left, both are equal magnitude, both will get cancelled. So here dE sin theta both are in the same direction. If two vectors are in the same directions, what we'll do? We'll directly add it. If two vectors are in opposite directions, what we'll do? We'll directly subtract it. So here we will directly add these two vectors, okay, and here it is opposite. So what I am trying to say will be here, you consider this pen, I have placed in this pen will be here. Now it is like a two quadrant circle, correct? Two quarter circle, one towards right and one towards left. So the dQ dl on the right side and dQ dl on the left side both are symmetrical. So according to this pen, with respect to this pen, it's a symmetrical structure. In biology also you have learned, right? Symmetry, asymmetry, bilateral symmetry, radial symmetry, the same way. So this is pakka symmetrical structures towards right and towards left also. So towards left and towards right, if it is maintaining some symmetrical structure exactly as like this example, then what will happen? The cos theta components will get cancelled and sin theta components will get added up. So I can say my total electric field, okay, so E net, my total final electric field at this point E net will be equal to integration of many dE sin theta. Here also I will get one dE sin theta, dE cos theta, here also, here also, here also, here also, here also, but all cos thetas will get cancelled, sin thetas will get added up. So we'll continue and dE sin theta. This is what kind of structure? This is a semicircle. So what is the limit from here to here? What is the limit of this one? 0 to pi, 0 to 120 degree or 0 to pi, whatever you can say. Now we'll write it for dE. dE is what? K into dQ divided by, okay, distance from here to this point. This point we have to get, this is nothing but the radius distance. So K into dQ divided by R square into sin theta. Okay, integration limit will be here 0 to pi. As like we have done previously also, we are going to solve what is the value of dQ, then we'll substitute here and we'll continue. Okay, so we'll make a margin will be here, we will resume it later. First we'll find out what is called a dQ. So as I told, always lambda, linear charge density, because it is a wire is related with the lambda. So lambda equal to charge divided by total length, of course. So in this case lambda equal to dQ divided by dl, dQ divided by dl. So dQ will be equal to lambda into dl, just cross multiplied. What is dl? In maths you have learned one concept is called angle equal to arc length divided by radius. If angle is d theta means if strips into small angle, I'll put it like this, he strips into small angle, he strips into total width on this one, so the strips will create an angle called d theta. So angle will be equal to this arc length, so this arc length is how much? It is given as dl. So angle is d theta, arc length is dl and radius is r. So we are substituting here angle d theta equal to arc length is dl divided by radius r. So dl I can substitute, dl will be equal to r d theta. All these steps we are going to apply will be here and we'll see what is happening. Okay, So I am continuing from the steps. He will be here integral 0 to pi k into dq. What is now dq? Dq is lambda into dl. Lambda into what is dl? R d theta whole divided by, already will be there, what is called r square sine theta. What is common will be here? K lambda is common. We can take it out of the integrations. K lambda into 0 to pi, r square r will get cancels. So what is coming? Sine theta d theta, and this r and this r get cancels, and denominator 1 r extra. So k lambda divided by r. We are applying the limit k lambda divided by r. What is the integration of sine theta? Cos theta or minus cos theta? Minus cos theta. So differentiation is sine theta into differentiation cos theta, sine theta into integration is minus cos theta. Integration limit from 0 to pi, minus we take it outside. So k lambda divided by r into cos of pi minus cos of 0. What is cos of pi? Cos of pi in the value is how much? Minus 1. Cos 0 in the value minus 1. Sorry, not minus 1, 1. So here it is minus 1, minus 1. So totally how much is this one? This one is comes with minus 2, and this minus 2 with this one. So I get written as k lambda divided by r. We are just substituting the value, that's all. Minus 1, minus 1. So this is minus 2, minus 2 become 2. So 2 into k lambda divided by r. This is the final electric field created by a line charge, but it is in the form of a semicircle. Okay, so 2 into k lambda divided by r. Whatever we have done for a normal wire which is in the form of a strip, the same concept we are applying will be here, but a slightly difference because of this bending structure. Cos theta, sin theta will be coming to pictures, and we are solving. Always we are finding dE. Sin theta will be there because dE cos theta components will get cancel it out each other because of the symmetry. Whatever in the right, same thing will be available in the left. So this x-axis component will get cancelled. Sin theta will get added up, and dq terms we have replaced. Now here I have a questions to you. What is the value of lambda? Can you think for a moment and tell me what is the value of lambda in this case? Lambda, you will say it is written in the board, right? I have already written in the board lambda equal to q by L, but the accurate value, the exact value of this lambda will be equal to charge by length. What is the length of this one? This is I have written as length. So what is the length of a half circle? A full circle length is 2 pi r, perimeter of the circle. So half circle is how much? Pi r. So remember this also, because normally in your entrance examinations they will give you a strip, okay, and they will ask you to find out various things which is related to the strips. So 3 questions will be coming from the sessions. Okay, I'll tell you the 3 questions. What are 3 questions they are going to ask? Question number 1, they will give you a strip like this one, and they will ask you what is the value of electric field intensity at this point. You directly know the value 2k lambda divided by r. K is 1 by 4 pi epsilon 0 lambda divided by r. This is already came for the entrance examination. Question number 2, they will give you all the values, and you have to substitute in this formula, and you have to find out the answer. But while you are substituting the formula, the one thing it's not given to you is called lambda. Lambda you have to find using this equation. Charge will be given to you, radius is given to you, but lambda is not given to you. So do not wonder during the time. It is lambda equal to q by pi r. Substitute it and you will get the answer. Question number 3, most important one. The electric field here, it is created. I have written the formula 2k lambda divided by r. Electric field is a scalar quantity or a vector quantity. Of course, from this one it's very clear electric field is a vector quantity, because wherever I am marking electric field will have a direction, either towards left or towards right or towards bottom. In this case, final electric field direction is where? Final electric field direction is towards down, because all the dE sine theta I have added it up and then I will got the final equation, which means the final electric field is along the negative y direction. So the same equations whatever I have written will be there in a vector format. I am writing vector E will be equal to 2k lambda divided by r. Whatever I am writing, same thing will be there, but in vector format. In what directions? Minus j direction the electric fields are pointing out. So 3 questions have discussed. Remember these 3 things. This will comes as a questions to you. Hope so. Remember the concepts. Okay.